Let's look at a couple of story problems that involve vectors. Here's this first one. Two forces of magnitude 10 newtons and 30 newtons act on an object at angles of 30 degrees and negative 45 degrees, with the positive x-axis as shown in the figure. Find the direction and magnitude of the resultant force. So they want the answer in the form of IJ. So basically what's happening is we're basically going to add these two vectors. That's it. That's just adding two vectors. Now the tricky thing is both vectors are given to you a magnitude and direction. We cannot add vectors together when they're in the form of magnitude and direction. The only way we can add vectors together is if the vectors are in the IJ form. So what we're going to have to do here, we're going to have to take vector F1, convert it to IJ, take vector F2 and convert it to IJ, and then we can add them, and then that should be the answer. So let me actually do this on a separate piece of paper so I have plenty of room. This is a fair amount of work involved here. So let me get to focus. So F1, it's like 30 degrees and magnitude of 10. F2, I draw much longer because this represents a force of 30 newtons. So the point of this problem is but like I just said, I can't add them together unless they're in IJ form. So let's take F1. To put in IJ form, you take the magnitude times the cosine of the angle. That becomes your I part. Plus the magnitude times the sine of the angle. And that becomes the J part. Oops, it's actually 30 degrees. Since we're wanting exact answers, these are special angles. Cosine of 30 is square root of 3 over 2, so 10 times square root of 3 over 2 should be 5 square root of 3i. And 10 times sine of 30 degrees is 1/2. Now you can look, so this vector, the I is positive, the J is positive. It makes sense because this vector's up here in quadrant 1. Now F2 is tricky. I'm not going to use minus 45 because when we do problems like this, this is really the angle I'm going to use for this force. Because we start at positive x-axis and we go counterclockwise. So if this is minus 45, subtract that from 180. This is actually a 135 degree angle. So what I have is the magnitude times the cosine. Oh, sorry, wow. I should subtract it from 360. So sorry. So it's 360 minus 45. I'm going to cut that. So the angle is really 315. And then the J part is 30 times the sine of 315 degrees J. So this is a special angle. Down here, it's in the fourth quadrant. The cosine would be square root of 2 over 2. So 30 times square root of 2 over 2. It's going to be 15 square root of 2. Then 30 times square root of 2 over 2. So 15 square root of 2j. Except, be careful now, this should be minus. That's where it's good to have a graph, because I know the j is going to be minus. So now that I have the F1 and F2 vectors in IJ form, F1 plus F2 is just when I add them together. So the I parts, square root of 3, square root of 2, I can't combine these. These are not like terms. I just have to write them both out. So it'd be 5 square root of 3 plus 15 square root of 2. That whole thing is the I part. And then the j part would be these, which I also can't combine. 5 minus 15 square root of 2 would be the j part. I'm thankful I caught that one error, and hopefully that was the only one. And that looks correct. So really it's a problem of adding two vectors together, but you have to first put them in the IJ form. All right, last problem. Story problem again, about an airplane. Let's see if we can read this. An airplane has an airspeed of 470 kilometers per hour, bearing north 45 degrees east. The wind velocity is 60 kilometers per hour in the direction of north 30 degrees west. Find the resultant vector representing the path of the plane relative to the ground. What is the ground speed of the plane? What is its direction? So this plane is flying, and because of the plane motor itself, it can go a certain speed and a certain direction. But up in the atmosphere, there's wind blowing, and the wind is trying to push the plane in a different direction. So it's like these two forces, the force of the plane flying in a certain direction, but then the force of the wind blowing it in a different direction. So the question is, what direction and how fast does the plane end up going? So what you've got is you really have two vectors you're going to add together. One vector represents the plane, what it can fly on its own. The other vector represents the wind. So let's try and draw this. So it's almost like here's the plane. So on its own, the plane can go 470 kilometers and north 45 degrees east. What that means is north 45 degrees means you go north. North is going to be straight up. East is to the right. West is to the left. South is down. So the plane's going north 45 degrees east. You go north and you move 45 degrees to the east. So I'll call this the plane. So even though this is 45 degrees, that means this is also 45 degrees. And the magnitude, how fast it's going, is 470. So for this plane, magnitude 470, direction 45 degrees. Now the wind is 60, and it's north 30 degrees west. So north 30 degrees west means 30 degrees toward the west, but it is like 60 kilometers per hour. So you can imagine if I would draw it maybe like this. So this is like the wind. and the magnitude is 60. Let me draw in the angle. Oops, it's this angle. North 30 degrees west. That angle's 30 degrees. So hopefully you can see, let me write this down. For the plane, the magnitude is 470. The angle is 45 degrees. For the wind, the magnitude is 60. But the angle for the wind, if this is 30 degrees, then I have to add 90 to it. So the wind is actually blowing 120 degrees. I now need to add these two together. It's just like the last problem. I'm going to have to convert them to the IJ form and then add them together. In this case, I've got to convert to IJ, add them together. After you add them together, you have an answer in IJ, but then I have to convert IJ back to magnitude and degree. So it's going to be a fair amount of work. So for the plane, magnitude times the cosine of the angle, 45 degrees, that's the I part, plus 470 times the sine of the angle. And here they don't ask for an exact answers, so I'm going to start using my calculator pretty soon. And the wind, magnitude 60, the angle is 120, cosine of 120, there's the I part, plus 60 sine of 120, there's the J part. I'm actually going to grab my calculator and I'll probably leave like 2 significant digits. So I'm in the degree mode, cosine 45 times 470, 332.34. And 470 times the sine of 45 degrees, actually, it's going to actually be the same. Sine and cosine are the same. Although it is going to be, yep. Now 60 times cosine of 120. 120 cosine times 60 plus negative 30. That's the I part. 60 times the sine of 120. $51.96. We should see if this makes sense. So we're saying the wind, X is like negative, Y is positive, should be second quadrant. Yeah, the wind's in the second quadrant. Now, we can add these together. In a sense, I'm subtracting, so it's probably dangerous to do it in my head, but I think 302.34. I don't want to mess up. Let me just do it. 332.34 minus 30. Yep. And here I'm adding these together. Maybe I can add them. So this is like a 0. You carry the 1. It's like 13. You carry the 1. 4. 38. $384.30. So that is, and we'd expect, if we imagine this is a lot stronger, this is different direction, a lot smaller, maybe the resultant vector is like this. Now, I need to get the magnitude, because I want to put the answer in the same form that the question was stated. This is like going to be the overall speed of the plane. By itself, the plane can go 470. The wind is pushing it in a different direction at a speed of 60. So this ends up being the overall speed. So I'm going to take this 302.34, square it, and add it to 384.30 squared. Add those and take the square root, and you get 488.97, or basically 489. So that's how fast the plane is going, kilometers per hour. Now they also want the angle. So the J part over the I part, so 384.30 over the J part, or over the I part, 302.34. So grab my calculator, 384.30, 384.30 divided by 302.34 equals, take the inverse tangent, 51.8 degrees. And that looks like the answer. Don't have to do anything else. 51.8 degrees looks, except that's not got the answer I've got. Oh, one last step. Almost forgot this. Look at this in the box here. It doesn't just want the normal degrees. It wants the east of north. So I want to put it back when I call compass directions. So let me explain that. So 51.8 would maybe be like right here. But these compass direction, they always start with north or south. And we don't want to write this angle that way. So this is east. So they want to say the angle is north, a certain number, east. So you're going to take 90 minus 51.8. And you get 38.2. So this is actually 38.2. So you got north 38.2 east. Or they called it east of north. East of north, the same thing as north 38.2 degrees east. All right, vectors can be lots of fun.